Hi everyone, I'm Kirthana. My teammates are Harish and Harshavardhan. So the topic of a project is water monitoring system to monitor water level in the tank using microcontrollers. The abstract of a project is most of the people in residential area face the problem of running out of water and overflow of water in water tanks due to excess supply of water. It becomes difficult for users to judge the level of water in water tanks, due to which at times of need users may run out of water. Even when the pump is turned on, users will not realize when the water tank is filled, which may result in overflow. Water tank monitoring system is used to sort out the issues associated with water tank. It is also possible to check the level of water using sensors so that whenever the water goes below the criterion threshold limit, a notification is sent to the user through the Android app application and user need to turn on the pump. Also, when there is overflow of water in water tank, it uses sensor to detect the water level so that if the water level goes above the criterion limit, the pump gets turned off automatically. This system prevents wastage of water. Introduction. The water is a universal solvent which plays an important role in everyday life. The total amount of water available on Earth has been estimated at 1.4 billion cubic kilometers. About 95% of the Earth's water is unfit for human consumption. About 4% is locked in the polar ice caps, and the rest 1% constitutes all fresh water found in rivers, streams, and lakes, which is suitable for our consumption. A study estimated that the person in India consumes an average of 135 liters per day. This consumption would rise by 40% by the year 2025. This signifies the need to preserve our fresh water resources. Many houses make use of supplementary water tank to store water that is collected from rainwater or water pumped from well or underground. At present, water meters are used to calculate the amount of water used at homes. This doesn't provide an efficient method of monitoring the water usage. The water is wasted at each and every outlet, knowingly or unknowingly, which adds up to a huge amount in the end. Efficient management of water use at homes is very much necessary, as about 50% of water supplied to the cities gets waste through its improper usage. Water management is only possible if the user is aware of the quantity of water he uses and the quantity available to him. Hence, there is a need for modifying the traditional water meters for the users to continuously monitor their water usage, which is always not possible. At present, water meters are used to calculate the amount of water used at homes. This does not provide an efficient method of monitoring the water usage. So the main objective of a project is the system is to monitor the water level at rural areas so that they help in detecting the wastage of water, and measures can be taken to avoid unnecessary overflowing of water in the areas where monitoring is a difficult task. It consists of sensor devices which automatically detects the level of water inside any tank. The solution provides actionable insights for the managers to make wise and necessary decisions in situations of leakages or overspilling of tanks. So, the main methodology of a project. So, the first step is to connect the LCD to port 2, then connect the port P0.7 to the relay and P0.2 to full and P0.1 to half and P0.0 to 1 by 4th. That is a quarter. So if the tank is empty, it will display empty. If the tank is 1 by 4th full, it will display quarter. And if the tank is half full, it will display half. And if the tank is overflowed, it will display full. So the hardware used, microcontrollers 8051 with board, breadboard, and the NPN transistors, and the resistors, and the connecting wires, and 16 into 2 LCD display relay. And the software used is Scale Microvision.
As seen in this image, the microcontroller is connected to this breadboard. This breadboard is important for the functioning of finding the amount of water filled in this container. So there are three different wires connected to the P0.0, P0.1, and P0.2 of the microcontrollers. And the LCD is interfaced to the microcontroller port 0. Via port 2. Okay. Now we will come to the software analysis. At initial, we are setting P0.7. That means P0.7 equal to 1. This is for this is for instructing the relay module to allow current. And we are also clearing P0.1, P0.0, and P0.2. This is which is connected to the different water levels of the container via breadboard. Now, at start with a call initial. This means that this a call means we should calling a subroutine. So this initial subroutine is stored over here. This subroutine is generally to initialize the LCD. And we are also written other subroutines like data write, delay, and command write. Data write is to write data. Delay is to make a manual delay for better processing of LCD. And command write is used to write commands for the LCD. Okay. So till this line, the in LCD it will be written empty because there won't be the container will be empty. And when the water level reaches the 1/4 of the container, a signal is sent to the microcontroller and then P0.0 will become 1 and J and B, this means jump if no bit. So that means it will execute the next line. When we executing in LCD, it will be written as quarter. Okay. Similarly, when the water level reaches of port 0.1 will become 1. So then LCD will be written off. And at last, when the water level reaches the top of the container, a signal is sent through the breadboard to the microcontroller and P0.2 becomes 1. Then in the LCD, full is printed. Before that, P0.7 is also restricted, that is, it will turn to 0. Then it will instruct the relay module not to allow current.
This is the water monitoring system to monitor water level in the tank using the microcontroller. Here in the LCD panel we can see it is written empty. So when we fill that water in the tank, in the LCD panel we can see it is quarter because quarter of the tank is filled with water. So again, when we fill the tank with water, so in the LCD panel it is written off because half of the tank is filled with water. So again, if we fill the tank with water, in the LCD panel it is written full. Thank you. Relay switch module. Since we are in the shortage of the relay switch model, we couldn't be able to connect it to our microcontroller project. This relay switch model should have been connected in the port P0.7. This model is capable of switching the devices on and off accordingly. It is ideal for applications where one needs to control the liquid level of a tank. In such applications, whenever the liquid level is at minimum, the min limit sensor should trigger the relay powering the pump on and filling the tank with the liquid. Once the liquid level has reached the maximum level, the max limit should trigger the module and make the relay switch the pump off and so on. The port 0.7 is theoretically connected to the relay switch module, so it will be set to low, which is 0. Hence, the current will not be allowed to pass. Overview. In the model is XH M2203. The working voltage is AC plus DC 5V. Output capacity is 10 amperes and output type is relay output. Conclusion. Nowadays, water is being wasted in many ways, and wastage due to overflowing of tanks is major contributor for this. Thus, water tank monitoring system helps to reduce the wastage of water due to overflowing by automatically turning off the pump when the water level in the tank reaches a threshold limit. Proposed system can also be enhanced by monitoring the entire activity through an app. An application is developed to help the users turn on the pump as shown in the experimental setup and off the pump when the tank is empty automatically. Thank you.